Hello there, and welcome to Earth Before Light, the place where we let curiosity wander without a timer and give big questions the time they deserve. This isn't the sort of space for rushing through bullet points or hurrying to the end. If Earth is a test, then the room we're sitting in seems precisely prepared. Our planet isn't just habitable, it's calibrated. We orbit in a band of distance that's neither a kiln nor an icebox. The Goldilocks zone, where liquid water can persist. Our magnetic field wraps around us like an unseen cloak, deflecting solar wind that would strip the atmosphere bare. Seasons arrive with enough rhythm for life to plan and adapt, but not so violently that every year is a lottery. Even the tilt of our axis and the pull of our moon read like careful dials. Tides breathe through the coastlines, mixing oceans, shaping where nutrients flow, perhaps nudging early life to explore new edges. Day and night trade places on a clock steady enough to train circadian rhythms. Those quiet clocks inside every creature that decide when to wake, feed, heal, and sleep. If you look at these conditions as instructions rather than coincidences, a different picture appears. Someone or something set the knobs so the test could run. The questions wouldn't just be about survival in chaos. They'd be about what we choose to do inside stability. What do we create when we're not busy going extinct? How do we treat each other when resources are neither constant famine nor constant feast, but a shifting mix that reveals our character under pressure? Maybe the real exam unfolds in those transitions. Lean years and abundant years, and in how we respond to both. Scarcity asks if we can share. Plenty asks if we can restrain ourselves. Predictability gives us space to cooperate. Unpredictability asks whether we will. And because no two lives are identical, it's as if each of us receives a personalized paper. Same principles, different variables. Some measurements would be slow, almost invisible, like watching empathy spread through families and communities the way a forest canopy knits itself leaf by leaf. Others would be sharp. Storms, losses, failures that test our reflexes and reveal the stories we live by. If a proctor wanted our unfiltered answers, they'd stay hidden, because once you know you're being watched, you start to perform. When you don't, you reveal. So, hold the question a little closer. If these settings aren't accidents, what are they inviting from us? Not just survival, but wisdom. Not just endurance, but care. In a world tuned for life to flourish, the most telling marks we leave may be less about how loudly we shout and more about how gently we choose. If you want to hide a civilization, you don't need a clever vault or a secret code. You need time. Time is the great solvent. It loosens every seam and softens every edge until meaning runs like watercolor back into the paper. Our planet is especially good at this. Plate tectonics drifts continents like slow rafts across a dark sea of stone. Ocean crust is born hot and bright at mid-ocean ridges, then creeps outward and finally dives back into the mantle, carrying with it whatever stories were written on its face. Even continents, supposedly permanent, rise, tilt, buckle, and erode. Mountains are made by collision and unmade by rain. Nothing on earth sits still long enough to be a perfect archive. Look closer, and you see 1,000 quieter erasers at work. Frost pries open concrete as easily as it splits granite. Roots thread through brick, widening hairline cracks into hungry mouths. Rust swells steel until it flakes, then flakes again. Acids in rain unlace the chemistry of marble and limestone, a molecule at a time. Rivers don't just flow. They remember gravity with an honesty that carves cities from beneath their foundations. Coasts breathe in and out with sea level, trading sand for streets, marsh for neighborhood, reef for road. A single hurricane can rearrange a century of shoreline decisions. 1,000 seasons can make a coastline forget it was ever mapped. Fossils, our favorite witnesses, are shy and selective. Most lives vanish without leaving any hard testimony at all. To fossilize, a body must be buried fast, spared from scavengers and oxygen, and then spared again from the grind of rock cycling. Even when fossils form, they're just snippets. A jaw here, a leaf there, a ripple of skin or feather pressed into silt like a breath you almost heard. If that's how poorly the record treats bones and wood, imagine the fate of polymers, wiring, glass, paint. Imagine the fate of us. In a few thousand years, skylines are forests with oddly rich soils. In a million, a metropolis might be a seam of chemistry, a little different from the muds above and below. We trust maps and deeds and photographs, but deep time has none of those. It writes in layers, pressures, isotopes, ink that needs patient eyes to read. So the real question isn't, where are the ruins? It's, what traces could possibly survive the world's hunger to recycle itself? Maybe a spike in certain gases locked into bubbles of ancient ice. Maybe a sudden rearrangement of carbon's isotopes in lake bottoms and sea floors. Maybe a dusting of rare metals where none should be. Maybe a horizon of tiny spheres, melted, fused, peculiar, spread thinly around the globe like the thinnest whisper of a fire no volcano made. This is not license to believe anything. It's permission to look carefully. Earth forgets loudly, but not perfectly. If someone came before, their last footprints wouldn't be monuments. They'd be faint signatures folded into stone and sediment. Subtle, testable, and easy to miss unless you know how to ask the question. Begin with humility and a field notebook. If an industrial civilization rose and fell in deep time, its cities wouldn't greet us with arches and boulevards. They'd arrive as chemistry. Geology keeps receipts, but they're itemized in elements and isotopes, not in letters and street names. So we ask, what receipts does industry leave that volcanoes, rivers, and wildfires rarely copy at the same scale or pattern? First, carbon, the handwriting of combustion. Burn enough buried carbon, and you tip the ratio of its stable isotopes worldwide. In rocks and seafloor muds, that shows up as a sharp, synchronous swing toward lighter carbon, a negative D13C excursion threaded through layers of the same age across far-flung basins. Nature can do this with massive volcanism or sudden methane releases, but an industrial pulse would pair that carbon swing with other, more telling companions. Black carbon soot spheres in unusual abundance, fly ash particles with distinctive shapes, and a dusting of metals from smelting and fuel impurities distributed on land and sea. Second, the periodic table's confetti. Human metallurgy already sprinkles sediments with odd enrichments. Lead, copper, zinc, chromium, nickel. Sometimes in ratios hard for volcanoes and rivers to mimic. Look for thin horizons where many of these rise together. Stay elevated for centuries to millennia, then ebb. Pair that with mercury anomalies that don't match known eruptions, and with rare earth element patterns that whisper refinery, not rift. Third, molecules that don't belong. Some synthetic organics are stubborn. They fragment, but their byproducts can persist in cold, low oxygen muds. Halogenated residues, long-chain fluorinated ghosts, or polymer-derived microfragments fused into plastiglomerates can become part rock, part artifact. Even if most plastics decay, a global sprinkle in the right layers, especially far from coasts, would be a curious chord to hear repeated. Fourth, the clock we set off ourselves. Artificial radionuclides. Mid-20th century, nuclear testing painted the planet with a wafer-thin layer of isotopes that simply don't occur in nature at appreciable levels, signatures with half-lives that let future readers date our moment to the decade. If any prior civilization split the atom, we'd expect a similarly skinny, synchronous horizon of fallout in lake cores and marine clays, faint but planet-wide. Finally, the pattern of change. Life responds, warm the climate quickly, acidify the oceans, shuffle nutrients, and ecosystems stutter in ways we can count. Extinctions bias toward certain habitats, a sudden rearrangement of pollen and plankton communities, opportunistic species surging into the gaps. In the rock record that looks like an ecological snap, not a yawn layered right on top of the chemical signatures. None of these clues alone would convict industry beyond reasonable doubt. The Earth has its own factories, volcanoes, anoxic seas, asteroid winters, but a stack of clues, time-locked together across the globe, begins to look less like coincidence and more like intent. That's the test. Not a single smoking gun, but a chorus of small voices singing the same strange song. The challenge with reading the planet's diary is that nature loves to imitate us. A colossal volcanic episode can flood the air with CO2, turn oceans acidic, dust the world with metals, and leave behind ash and soot that harden into rock. Bursts of methane from thawing clathrates can push carbon isotopes in the same lighter direction that burning fossil fuels does. Even impacts from space can scatter strange glassy beads and rare elements across continents. If you find any one of these clues in isolation, the Earth can shrug and say, "I've done that trick before." So scientists frame the puzzle like a detective would. Never trust a single fingerprint. Look for a pattern that's hard to fake. Imagine opening a core of ancient seafloor mud and seeing, all stacked together in the same thin band, a sharp, planet-wide swing in carbon isotopes, a surge of industrial-looking soot spheres, odd enrichments of several metals in lockstep, and biological changes that happen abruptly rather than lazily. Add to that an appearance, however faint, of molecules that don't assemble themselves easily in nature, and you start to hear a chord that volcanoes or landslides rarely play in unison. There's a name some researchers borrow for exploring this idea. Half in jest, wholly in rigor, the Silurian hypothesis. After a piece of old science fiction, it doesn't claim our planet hosted engineers in the Silurian period. It asks a clean, testable question. If a technological civilization had flared and faded at any time in deep history, would geology let us spot its echo without a single artifact in hand? The answer demands patience, because deep time is noisy and the signals we want are subtle. Many past warming events, oceanic anoxic events, and ecological jolts pepper the record. Some share features with the wake we're leaving now. The task is not to force a match, but to learn which combinations of signals are uniquely industrial and which belong to Earth's own dramatic repertoire. Where would we look? In places that hoard memory, quiet, low oxygen basins where mud accumulates faster than it is disturbed, lakes that lay down paper-thin layers each year, like rings in a tree, stalactites and stalagmites that drip their chemistry, drip by drip for ages, peat bogs that pickle the past. Even ancient permafrost and relic ice can trap tiny bubbles and dust that tell what the air once held. In each archive, the question is the same. Is there a skinny horizon where too many unlikely things happen together at once around the globe? Humility is the posture that keeps this honest. This isn't license to declare every odd layer a lost city. It's permission to ask sharper questions of the rocks. If the answer is no trace, that too is a result. One that teaches us how very briefly the earth remembers even loud events. And if the answer is maybe, the only honest response is to test, and test again with new cores, new proxies, and new eyes. To imagine a civilization before us, you have to first loosen your grip on the map, the outlines you know, the comforting jigsaw of continents are only a single frame in a film that's been running for hundreds of millions of years. Long before people drew borders, the world's crust drifted like slow ice on a dark sea of rock. Plates split, drifted, collided, and folded. Mountain ranges rose where oceans once swelled. Coasts crept inland, then fled, tracing shapes you wouldn't recognize even if you hovered above the planet with a God's eye view. If a culture blossomed in one of those vanished arrangements, its neighborhoods might sit today beneath a desert, beneath a forest, or far offshore, under cold black water and miles of silt. The earth of deep time wasn't empty. It was loud with life. Creatures filled every niche, not as rehearsals for us, but as their own completed stories. Some were familiar in posture, if not in detail. Others were beyond analogy. Bodies written with alphabets evolution no longer uses. Intelligence was not a single spark waiting for humans. It was embers scattered widely. You can see its hints today in animals that plan, remember, teach, and improvise. Given ages upon ages, those capacities could have braided themselves into cultures, then into technologies suited for bodies nothing like ours. And yet the ground keeps moving. That's the central cruelty of searching the deep past. The archive reshelves itself while you're reading. Oceanic crust is born hot at mid-ocean ridges and sinks back into the mantle within 200 million years, carrying with it whatever story was printed on its skin. Continental crust endures longer, but it is hardly a vault. It thickens and buckles, bakes and warps, then erodes grain by grain into rivers that forget their source. A city needs stillness to remain a city. The planet refuses stillness. Even the climate, the stage set, refused to hold. There were epochs when the air was heavier and warmer, seas higher and swarming with carbonate-shelling plankton. Others, when ice shouldered its way down from the poles, grinding mountains into powder and locking away oceans. Shorelines wandered with the temperature, offering and then snatching back the gentle estuaries where we tend to build. If the first engineers loved coasts as much as we do, so much of their work would have been drowned, pulled apart by waves, buried under ever-thickening blankets of mud. So when you hear, "Where are the ruins?" listen carefully for what the question assumes. That ruins survive where we can easily walk to them. That the horizon hasn't rolled over the foundations. That stone has kept its shape and meaning. But the earth prefers whispers. The proof of deliberate lives might be a paper-thin horizon of chemistry in a lake's layered silt, an odd blend of metals in a cliff face, or a global pulse of lighter carbon woven through seafloor mud. That is what endures when maps won't sit still. Patterns, not monuments. If someone came before us, they grew up on a planet that never stopped rewriting the ground beneath their feet. Their memory would have had to stretch across moving continents, rising seas, and climates that breathed in ice and exhaled heat. Our task is to learn to read the faint, migrating ink those lives might have left. Ink that doesn't form letters, but still tells a story if you're patient enough to follow it. If earlier makers loved the shore as much as we do, their handiwork would not be on mountain tops. It would be underwater. Coasts are magnets for settlement and engines for forgetting. Rivers bring not just fresh water and food. They deliver silt by the fistful, day after day, until streets, wharves, and refuse disappear beneath a patient snowfall of mud. Then the sea rises, as it always does given enough time, and lays a quiet hand over everything. Deltas grow, estuaries deepen, shorelines unspool and rethread themselves a little farther inland. A civilization that flourished along a long-vanished coast would now be sleeping beneath the continental shelf, under cold darkness and a quilt of sediment thick enough to turn history into geology. Shelves are the planet's attics. During ice ages, when the seas retreated, rivers cut canyons across those wide, exposed plains, carving stair steps toward the edge. When the water returned, those drowned valleys filled with layered stories, floods and droughts, storms and calms, and the traces of lives lived nearby. If anyone smelted metal, burned fuel, dyed fabrics by the ton, or farmed intensely, the shelf-edge mud should remember in chemistry what the eye can no longer see. Some basins are better archivists than others. In places where deep water sits still and oxygen runs thin, the Black Sea, or smaller pockets like fjords and silled basins, bottom life that loves to dig and churn can't survive. Sediment settles into tidy laminae, year upon year, as crisp as notebook paper. Within those thin stripes, you can count seasons, storms, and out-of-place ingredients. A sudden dusting of metals in unusual ratios, soot spheres that look less like wildfire and more like furnaces, a brief surge of nutrients that reorganizes microscopic life, then fades. Not a monument, but a fingerprint. The search would be slow and exacting. You'd core the shelf in transects from old river mouths toward the deep sea, reading each cylinder like an ECG of a coastline's past. You'd look for horizons where many unlikely things happen together. A carbon isotope swing, a spike in certain metals, a population flip in plankton, and tiny industrial-looking particles, locked to the same few centimeters of mud across distant sites. You'd check quiet lakes inland as controls, those that lay down annual couplets of light and dark, varves, so you can pin a sequence of years to the strange layer. You'd peer into stalagmites in coastal caves, where drip water captures what the winds and rains once carried, to see if their slow-growing bands echo the same brief, odd chemistry. Of course, nature has its forgeries. Volcanoes can dust basins with ash and metals. Wildfires can stack soot. But patterns betray pretenders. Eruptions speak in shards of glass and certain element pairs. Fires cry in charcoal that looks different under a microscope than fly ash from a stack. An industrial chorus would sound like too many instruments playing at once, on beat, across the map. If someone came before us and built by the tide, the shelves are where their last echoes live, not temples in the sand, but thin, quiet lines, waiting for a careful hand to turn the page. Imagine the core lab at midnight. The room is quiet, except for the soft thaw of ancient mud and the hum of a microscope. In the clear dish before you, a world too small to see with the naked eye is crowded with clues. If cities sink into silt and monuments collapse to sand, what remains stubbornly legible are the tiniest byproducts of making, burning, mining, and farming. The dust of intent. Start with spheres, not the volcanic kind, born in explosions and full of shattered glass, but the perfectly rounded, glossy beads that form when fuel ash melts in midair and cools as it falls. Spheroidal carbonaceous particles and fly ash spherules. Under polarized light, they look manufactured, smooth, uniform, sometimes magnetic from iron phases forged in high heat. Wildfires leave charcoal that splinters and frays. Volcanoes shed shard-like glass and crystal fragments. Industrial ash writes in circles. Then the metals. They rarely travel alone. In a thin horizon, you might find a choreography of lead, zinc, copper, chromium, nickel, vanadium rising and falling together across distant cores as if keeping time to the same hidden metronome. Look closer, and isotopes whisper provenance. Lead, for instance, carries ratios that point to specific ore fields. When a civilization digs and smelts widely, sediments record a blend of signatures that rivers and volcanoes seldom mix in that way. Mercury spikes can be imposters from eruptions, yes, but paired with those alloy-like ensembles and with ash spherules, the story bends toward furnaces, not calderas. There are ghosts of molecules too. Many synthetics fall apart, but their broken pieces can latch onto clay and linger. Halogenated residues, stubborn fluorinated fragments, or odd polymer derivatives can turn up in cold, low-oxygen muds where chemistry slows to a crawl. On beaches, heat can weld plastic and sand into plastiglomerate, ground fine and swept offshore. Such matter becomes a peppering of polymeric crumbs that, when fused into sediments, is less litter than lithology, a tiny telling rock. Agriculture leaves its own small handwriting. Fertilizer changes the ratio of nitrogen isotopes in lakes and estuaries and coaxes blooms of certain algae that settle into the record as sudden shifts in microfossil communities. Diatoms and foraminifera rearrange themselves. Opportunists surge. Diversity dips. Oxygen wavers. The mud keeps that pulse as a tight stack of annual bands. A decade, a century. Then a return toward normal once the pressure eases. Nature can overfeed waters too, but culture tends to do it synchronously across basins on a clock that looks planned rather than episodic. Combustion dust magnetizes history. Tiny iron-rich particles forged in engines and stacks align with a magnet. Sprinkle through a layer, they make a kind of compass you can measure. Another chorus member that rarely solos without ash spheres and metal anomalies. Even pollen testifies. If a species that loves disturbance rushes in everywhere at once, weedier plants elbowing into the mix, its grains pile up with a suddenness that matches the chemistry below. Forests can burn and regrow, yes, but it is the global timing that matters. Many unlikely things happening together in the same few millimeters of mud, far apart on the map. None of these micro clues alone proves civilization, but stacked, spheres with metals, metals with odd molecules, molecules with ecological jolts, they form a pattern that looks less like the heartbeat of a volcano and more like the breath of industry. When the monuments are gone, the microscope becomes our cathedral, and its stained glass is a scattering of dust that refuses to forget. If stone is an archive, carbon is its index. Every breath of a planet leaves a mark, and in the rock record those marks are ratios, whispers inside atoms that tell you how the air once felt against the ocean's skin. When living things bloom, they prefer lighter carbon 12C over its heavier sibling 13C. When they die and are buried, that preference gets filed away in mud and limestone as D.C. A tiny tilt in the balance that geologists can read like a date stamp. Tip the world quickly, warm it, starve or stuff it of nutrients, flood it with carbon from ancient stores, and the deep teensy needle jumps. Not months, not headlines, but a sudden swerve at the scale of geologic patience. This is why a single thin band of lighter carbon spread through many basins at once is so intriguing. Volcanoes can do it. Thawing methane can do it. Oceans that choke on their own productivity can do it. But pair that carbon swing with soot spheres that look poured rather than splintered, with alloy-like ensembles of metals in ratios more refinery than rift. And the story begins to sound less like a tantrum of nature and more like a planet briefly breathing through engines. Carbon doesn't walk alone. Oxygen carries a diary too. The ratio of heavy to light oxygen, the 18O, in the shells of tiny foraminifera, records a blend of temperature and ice volume, a proxy for how warm the seas ran and how high the glaciers climbed. Stack D18 beside D18C, and you can see not just that the world changed, but how it changed. A quick fever, a drawn-out recovery, a pulse of melt water. Add boron isotopes from those same shells, and you get a sketch of ocean acidity, a window into how much CO2 once pressed on the sea and how the waves answered with bite or balm. There are thresholds that oceans guard like gates. Deep water holds a line, the lysocline, below which calcium carbonate dissolves more readily. Shoal that line upward by acidifying the oceans, and chalky sediments vanish, replaced by darker clays. In cores, that looks like the music suddenly losing its high notes. If at the same horizon you find a negative D13C excursion, a D18O nudge toward warmth, and a dimming of carbonate, you're hearing a chorus. The air grew heavier with carbon, the seas warmed and bit back, and the chemistry flinched. Nature has sung this chorus before. The hard question is whether any verse carries the timbre of intent. Timing is the hinge. Natural upheavals often ramp and fade on the scale of tens to hundreds of thousands of years. Industrial pulses, by their nature, compress centuries of change into the thickness of a fingertip in a core. In varved lakes, where each year is a page, the difference between a human century and a geologic one is legible. A handful of pages browned and crowded with odd ink versus a whole chapter written slowly by wind and tide. And then life answers. In the same slim band where the isotopes swing, species reshuffle. Warm water plankton steal territory. Opportunists bloom. Oxygen wavers in bottom waters. Then patterns either recover or reroute. Civilization, if it ever shared the planet with those proxies, would be less a statue in the rock than a gasp in the carbon clock. A synchronized, slender pivot in many measures at once. We are right now writing such a pivot that doesn't prove anyone did so before us. But it teaches us what a deliberate century looks like in stone, and it gives us a template to search for its elder echo. If the idea is bold, the method must be gentle and exact. to ask whether someone came before us without fooling ourselves. We have to treat the planet like a witness, not a prop. Pose clean questions, accept plain answers, and set guardrails against our own hunger to find meaning. Here's what that looks like when you strip the romance away and keep the wonder. First, write the hypothesis tightly enough to test. There exists a globally synchronous layer, thinner than a human lifetime, in varved lakes and centimeters in marine mud, marked by a negative D13C swing, B, co-occurring anomalies in suites of industrially linked moths, metals, C, an abundance of spherical fly ash-like particles, and D, an abrupt ecological reordering. This layer is not associated with known large igneous provinces, impact markers, or documented natural anoxic events. No hedging, no wiggle. Second, pre-register the plan. What cores, what depths, which proxies, which statistics, before the first sample is opened. The point isn't bureaucracy, it's humility. When the steps are public, the result can't be accused of wishful tuning. Third, choose archives that don't talk to each other. A Black Sea core, a high-altitude varved lake, a tropical anoxic basin, a peat bog, a stalagmite from a coastal cave, and a pelagic, deep-sea site, far-flung in latitude and chemistry. Synchrony across difference is the whole test. If the signal is real, it should arrive like the same note played on different instruments. Fourth, blind the analysis where you can. Let one team measure isotopes without knowing where the suspected horizon lies. Let another count spheroidal particles and characterize metals. Let a third reconstruct microfossil communities. Only at the end do you stack the transparencies and see if the spikes line up. The Earth gets the last word. Collaboration keeps us honest. Fifth, benchmark against nature's best imposters. Assemble libraries of signatures from eruptions, methane releases, wildfire pulses, impacts, and known oceanic anoxic events. If your strange layer is just a costume nature wears often, those wardrobes will reveal it. If it isn't, the differences will survive the comparison, subtle but stubborn. Sixth, time it. In varved lakes, count years grain by grain across the horizon. In marine cores, use multiple clocks. Magnetostratigraphy, tephra-ties, radiometric anchors, to confine the thickness to decades or centuries. Human scale change should be geologically thin. If the band sprawls across tens of thousands of years, it's almost certainly the planet talking to itself. Seventh, invite replication and failure. Publish the methods with enough grit and detail that a stranger can retrace every step. Ask critics to pick new sites, flip the latitudes, swap the basins, and try to make the signal vanish. If it persists, it's won its right to be believed. If it dissolves under scrutiny, the negative is still a portrait of how fast Earth heals its own disturbances. This is how you ask a fair question of stone, not by insisting on a story, but by building a corridor where any honest answer can walk through. And then you listen, because listening is the first craft of science and of memory. Our search is biased toward what we know how to make. We look for iron's red memory, for copper's green patina, for the stubborn glitter of chromium and nickel. But what if the cleverest machines of a bygone world were built from things that choose to disappear? Imagine technologies grown rather than forged. Composites spun by engineered fungi. Resins expressed by plants. Structural fibers braided from chitin or collagen analogs. Circuits printed in conductive biopolymers that quietly compost back into soil when their work is done. Given enough time and pressure, those marvels would merge with the dirt that fed them, leaving only changes so soft we might mistake them for the background hum of life. Energy needn't announce itself with smokestacks. A civilization fluent in biology might have run on gradients invisible to the eye. Microbial fuel cells stitched into wetlands. Photosynthetic panels that were more leaf than lattice. Catalysis tuned to sip rather than gulp. Heat could have been low and local. Waste could have been food by design, not by accident. Where our age writes a bold chemical signature, theirs might have written cursive, legible only up close, and then only if you know which loops to follow. Even metals are not a guarantee of permanence. High-value alloys circulate endlessly if recovery is a cultural reflex. Picture tools designed for disassembly, appliances that announce their element maps to scavengers, cities where nothing rests idle long enough to become ruin because there is no such thing as a way. After a collapse, slow or sudden, what remains would be swiftly harvested by the last networks that still work. Fungi, water, wind, and the hunger of survivors. By the time forests return, the ground would hold only a faint enrichment of elements spread too thin to alarm us. Then there is the ocean, the great dissolver of evidence. If most industry happened offshore, anchored to platforms of woven biocomposites, powered by currents and light, the archive would be even stingier. Storms tear, borers chew, Salts infiltrate, mud buries. What persists are chemical murmurs in layered clays and tiny shifts in the census of plankton. The seafloor does not keep monuments, it keeps moods. We also have to question our sense of scale. We equate civilization with sprawl, mass, glare, because that is the story we've written. But intelligence doesn't require continent-spanning grids. It requires continuity of knowledge, a steady handle on energy, and a way to make meaning travel farther than bodies do. A small distributed culture could reach extraordinary subtlety without ever needing to stack stone into sky or mine mountains hollow. Its footprint would be a network, not a stamp. Its afterimage would be coherence, briefly imposed on ecosystems and chemistry, then let go. This isn't special pleading for ghosts. It's a reminder that our detectors are tuned to our reflection. If someone came before who chose materials that return themselves, energy that whispers, and scales that avoid spectacle, we will only meet them by training our eyes on the faint, the thin, and the almost normal, and by admitting that vanishing can be a design, not a failure. When the chemistry of a world changes quickly, life doesn't hold steady and smile. It stutters. In rocks, that stutter shows up not as a headline, but as a rearrangement of the cast. Some players vanish, others surge into the light. Still others shrink into corners and wait it out. If an industrial century or two once unfolded before ours, we might expect to find its echo less in monuments and more in the choreography of shells, spores, and pollen suddenly out of step. Begin at sea, where the planet keeps its most meticulous diaries, tiny foraminifera. Those chalky, single-celled architects are exquisitely choosy about temperature and acidity. Warm the surface waters fast, and some warm water species sprint poleward while cold lovers retreat. Make the ocean bite a little harder with carbonic acid, and the delicate carbonate-bodied forms falter. Tougher silica-shell diatoms or opportunistic, mucus-rich producers can bloom instead. In cores, that looks like an abrupt flip in microfossil communities layered right on top of the isotope swerves we already watch for. A chorus changing keys without warning. On land, pollen becomes a crowd scene that suddenly shuffles. If forests are cleared on a wide scale, by fire, by grazing, by deliberate cutting, grains from disturbance-loving plants surge. Ragweeds, grasses, light-hungry pioneers. Their rise is natural after storms and lava. Yes, but civilization tends to synchronize the disturbance. The same weeds swelling at the same time across distant basins is not a storm. It is a policy written in seeds. When the pressure eases, shade-tolerant trees tiptoe back. But the gap years are there in the record like a skipped a heartbeat. Then there is the quiet signature of nutrients. Agriculture is generosity aimed with intention. Nitrogen and phosphorus poured onto fields and inevitably into rivers. Lakes remember that kindness as eutrophication. Thicker annual layers, sudden algal booms, oxygen-starved bottoms, fish bones thinning to absence. Then a recovery if the flood relents. Volcanoes and dust can overfeed waters too, but their timing is jagged and local. A civilization's overabundance arrives like a drumline, broad and briefly unstoppable. Extinctions tempt grand claims, but caution keeps us honest. Mass die-offs have happened without cities or smoke, impacts, traps of lava, seas that went anoxic for reasons of their own. What would be different under industry is bias and tempo. Losses would tilt towards specialists at the edges, corals near their thermal limits, coastal breeders whose nurseries turn turbid, deep water creatures if oxygen lines shoal upward. The pulse would be narrow in time, recoverable in places, asymmetrical on maps, human in its unevenness. Even genes might hold a faint aftertaste. Rapid range shifts and bottlenecks leave signatures in DNA. Clocks that tick in substitution rates and haplotype spreads. Those signals smear with ages upon ages, but in younger deep time, they can still whisper of a century when boundaries leapt faster than mountains move. None of this, alone, proves intent. Life has stumbled and sprinted for eons without our help. But stack these biological stutters atop the chemical hints. The carbon gasp, the metal confetti, the soot written in circles, and a picture begins to cohere. Not a planet in one of its ordinary moods, but a brief, deliberate rearrangement that life endured and then, resilient as ever, rewove into something new. If Earth is a poor archivist, the sky might be kinder. Our planet folds, weathers, and swallows its own past. The moon does none of that. No wind to round the edges, no rain to dissolve, no plate tectonics to shuffle the shelves. Only sunlight, micrometeorites, and long, slow time. If any earlier makers ever reached for space, even briefly, the best place to look for them might not be here at all, but out on that grey library in the dark. What could survive there? Not gleaming towers or crisp footprints after millions of years. Those are sanded down by micrometeoroid weather. But dense things endure. Glass fused by high heat. Slaggy beads from smelting experiments. Sintered bricks. Unusually pure metallic fragments in contexts where nature seldom refines. A landing site could fade into topography, yet leave a geochemical smudge. Alloys and glasses scattered in a patchy halo. Subtle, but alien to the moon's typical recipes. Buried a meter or two under regolith. Sheltered from the constant peppering, even delicate objects might persist as warped, unrecognizable fossils of technology. Mars keeps secrets differently. Thin air, cold deserts, and sediments that can sit undisturbed for eons make it a museum of surfaces. If someone a very long time ago sent simple probes, hoppers, gliders, balloons, or practiced with heat shields and aeroshells, we wouldn't expect intact machines now. We would expect odd oxidized patches with element ratios that don't match basaltic dust, tiny fields of fused material, or layered deposits with micro-spherules born of high-temperature processes no commonplace dust storm achieves. In ancient lake beds, a wafer of strange chemistry laid across the usual rhythms would be a flag, especially if mirrored at distant sites. Asteroids are the deep freeze of the solar system. Low gravity and no atmosphere make them unkind to anything that hits hard. But they are also repositories for fragments from everywhere. A technological culture that mined asteroids could have left tailings, piles of unnaturally sorted gravel, trenches with edges too straight for tumbling boulders, or exposed faces with cut-like geometries. Even after ages, redistributed debris could betray its origin in the mineralogical statistics. Improbable purities and element pairings. The way a sculptor's chisel marks hide in the marble's grain. And then there are the rings of our own sky. Orbits. Anything placed there eventually spirals down or drifts, but not without shedding a fingerprint. Long-lived debris fields can grind themselves to dust. Yet the dust falls, through time, into Earth's upper atmosphere. If, scattered across ancient polar ice or buried in deep ocean clays, we found a whisper-thin layer rich in alloys rare in meteorites but common in engineered objects, we would have to ask whose hands refined them and flung them aloft. This isn't treasure hunting. It's changing the map of where evidence could plausibly hide. The more we accept that Earth is a self-erasing slate, the more sensible it becomes to widen the search to places that keep. If someone reached beyond the cradle before the cradle forgot them, The cosmos may still be holding their last quiet breadcrumbs, waiting for eyes willing to see almost nothing as the beginning of a story. Every good expedition reserves a seat for doubt. Skepticism isn't a heckler. It's the safety rope that keeps us from stepping off bright cliffs. If we dare to ask whether someone came before us, the skeptic asks a sharper question. What if every signal we love has a perfectly ordinary explanation wearing an exciting disguise? History gives them ammunition. Consider the Paleocene-Eocene thermal maximum, around 56 million years ago. A swift warming. Oceans turned a notch more acidic. A pronounced negative. The 13C excursion. Biogeography scrambled. No smokestacks required. Just a pulse of carbon from Earth's own stores. Perhaps methane or volcanism routed through sediments. Or oceanic anoxic event too in the Cretaceous. Black shales bloom in the rock record, metals rise as life stumbles, and the carbon needle flicks toward light. Nature again, composing a familiar chord without our help. Even the razor-thin clay at the end Cretaceous, rich in iridium and peppered with glassy spherules, screams impact, not industry. The skeptic reminds us that volcanoes make metal anomalies. Wildfires sow soot. Methane burps can mimic our isotopic footprints. Currents and winds can synchronize change across basins without a single vote being cast. And the rock record is a master of pareidolia. Give it time, and it will carve straight lines, stack rhythms, and scatter spheres that look suspiciously intentional. So we tighten our standards. We don't accept a single clue, no matter how pretty. We ask for stacks. Industrial-looking fly ash spherules beside alloy-like metal suites. Beside a carbon gasp, beside abrupt ecological flips, locked to the same thin horizon across archives that don't talk to each other. We check that horizon against catalogs of imposters from lava floods, impacts, and anoxic events. We time its thickness. If it sprawls through tens of thousands of years, it's likely the planet. If it lives in the thickness of a fingertip and repeats worldwide, our eyebrows rise. But only then. We also police our own hunger. Confirmation bias is a patient sculptor. It can chisel patterns from noise if we let it. That's why protocols matter. Pre-registered methods, blinded analyses, independent labs, open data. The skeptic in the room demands that our excitement be reproducible by strangers. And there is a final, humbling possibility that industry can look exactly like nature in stone. If a prior civilization ran on biology, recycled to the bone, scaled softly, and loved the sea more than we do, then its wake might be faint enough to vanish into ordinary geologic weather. No evidence would not mean no one ever came. It would mean only that the earth is very, very good at forgetting. So we keep the skeptic close, not to mute wonder, but to tune it. If we ever do find a horizon where too many unlikely things sing in tune, the skeptic will be the first to nod, because we invited them to check the harmony from the start. If any ancient moment tempts us to whisper civilization, it's the Paleocene-Eocene thermal maximum, the PETM, about 56 million years ago. Open its pages, and the pattern looks eerily familiar at first glance. A sharp global lurch toward lighter carbon in the rock record. A sudden warming of the oceans and atmosphere. Seas that grow a touch more biting as dissolved carbonic acid climbs. Communities of tiny plankton and land plants shuffling their ranges like hurried passengers before a storm. On paper, that reads like a profile of industry's breath. Hold the page closer. The PETM is impressive, but it speaks in a tempo that belongs to the planet, not to factories. Its carbon swing, though abrupt by geologic standards, smears across thousands to tens of thousands of years. That is still lightning to a mountain. But it's not the fingertip-thin band a truly industrial pulse would lay down in varved lakes or fine marine muds. The PETM also carries the marks of huge natural reservoirs dumping carbon, likely methane or carbon-rich sediments, routed through volcanically warmed plumbing. Signatures we can track in the way carbonate sediments dissolve and then slowly recover. Think of a door pushed open and left ajar. Not a door flung wide and snapped shut within a human lifetime. Then there are the missing instruments in the chorus. The PETM's layers don't sing with fly ash spheres. The smooth glassy beads that engines and stacks rain down. Its metal anomalies don't stride together in the alloy-like ensembles that widespread smelting creates. Where metals do rise, they generally follow volcanic ash or changing redox conditions, not the industrial pairings we would expect to march in lockstep across oceans and continents. Its biological stutter, though dramatic, benthic foraminifera suffering on the seafloor, ranges leaping poleward, is paced like a long fever, not a century-long gasp. Even the geography of cause differs. The PTM's fingerprints cluster around natural plumbing, rift zones, volcanic provinces, sediments rich in carbon ready to be warmed and released. An industrial echo would look more globally democratic in its chemistry, spiking at once in basins that share nothing but the air and the rain. This isn't to tame the PTM into something ordinary. It wasn't. It was a planetary tipping that rewrote climate and life for a time. And it is one of our best teachers for how Earth responds when the carbon clock is jolted. But when we apply the stacked evidence test, tempo, particles, metals, molecules, and synchronized ecological shift, the PTM looks like a virtuoso performance by nature, not a lost recital by industry. Why linger here then? Because learning to say no with confidence is how we earn the right to say maybe elsewhere. Each case file we close refines the detector. It tells us which combinations of clues can arise without intent and which would be truly strange. The PTM also reminds us of a sober truth. Even a natural pulse, given enough time and mass, can push life hard. If a prior civilization existed but chose a softer footprint, recycling to the bone, whispering with biology, spreading its bets across seas, its wake could easily hide beneath events as loud as this. So we file the PTM under planet, not people, but we keep its lesson highlighted. The Earth is capable of writing stories that rhyme with our own. Our job is not to make them match, but to know the difference in the rhythm when they don't. If you want to see what a truly global, razor-thin horizon looks like, crack open the page the dinosaurs closed. 66 million years ago, a rock from space turned a warm afternoon into a boundary you can touch with your fingertip. In cliffs and quarries around the world, there's a wafer of clay, millimeters to centimeters thick, rich in elements the Earth's crust keeps scarce, dusted with tiny glassy beads and salted with a grief of soot. It is synchronized like a heartbeat heard on every continent. It is also, helpfully, not us. The signature is elegant and unambiguous. Iridium, rare in Earth's crust but common in certain meteorites, jumps sharply inside that thin band. Shocked quartz shows microscopic scars only an impact's violence can carve. Microtectites, glassy spherules spun from molten rock and flung high, rain back into the record like a storm of beads. In some places, a soot-rich sublayer speaks of global fire, forests and grasses igniting under a sky that burned. Above the line, the cast changes. Ammonites disappear from the seas. Many plankton groups stumble. On land, the pollen scene flips as ecosystems reset. It is abrupt. It is everywhere. and it is nothing like industry. That contrast is the lesson. Yes, there are spheres, but they are impact glass, not the smooth, iron-laced fly ash spherules that stacks and engines exhale. Yes, there are metal anomalies, but the cocktail is extraterrestrial. Iridium with its platinum group cousins, not the alloy-like sweets of lead, zinc, copper, chromium that smelting distributes. The tempo is appropriate for catastrophe, but wrong for culture. A single instant of violence, followed by years to centuries of fallout and darkened skies. Not the slender, century-scale pulse of coordinated combustion and agriculture. Even the ecology answers differently. After the impact, darkness and acidified rains write a chapter of trauma. Food webs collapse from the top and bottom at once. In an industrial pulse, we'd expect a different bias. Coastal life suffering first, carbonate makers eroding under acid seas, opportunists blooming in eutrophic waters, and a patchwork of recovery tied to where people lived and worked. The KPG boundary is democracy by disaster. Indifferent, immediate, planetary. So why linger here? Because it proves two vital points. First, the rock record can hold an event that's both thin and global. If industry ever wrote a narrow line worldwide, the archive has the fidelity to keep it. Second, patterns have personalities. A horizon can be synchronous and dramatic and still tell a story that no amount of wishful thinking can confuse with civilization once you listen for the right instruments. Set this case beside the PTM and you have a brace of calibrations, a long fever, natural carbon release, and a single blade thin wound, an impact. Industry, if it ever happened before, would likely sit between those rhythms. Thinner than the PETM, thicker and more chemically domestic than the KPG. That's the silhouette we carry into the next files, the template that keeps our questions honest. There are chapters in Earth's diary where the oceans sigh and stop breathing. Periods when deep waters turn disoxic to anoxic, when the seafloor becomes a dark factory of preservation instead of decay. We call them oceanic anoxic events, OAEs, and they tempt us because their pages look at first glance like industry's afterimage. Black shales rich in organic matter, metals spiking in strange patterns, isotopes of carbon swinging toward light as ancient stores are mobilized. If you wanted a natural counterfeit of a civilization's wake, you could do worse than an OAE. The recipe seems simple but is made of many hands. Volcanism, lifts CO2 into the air. Climates warm. Stratification strengthens so that surface waters no longer mix their oxygen with the depths. Nutrients pulse through rivers and winds, overfeeding the sunlit skin of the sea. Plankton bloom, die, and rain down like snow into quiet basins. Decomposition in the deep uses what oxygen remains, then switches to chemistries that favor the burial of carbon instead of its return. Layer by layer, a black notebook fills, fine laminations unbroken by burrowers, because the burrowers are gone. Trace metals enriched by redox antics. Fossils of plankton reshuffled by warmth and by plenty. This is the kind of horizon that can mislead us until we listen to its rhythm. OAEs, even the dramatic Cretaceous ones, take their time. They ramp, sustain, and fade over tens to hundreds of thousands of years. Their chemistry is theatrical but patient. Molybdenum and vanadium rise with sulfidic waters. Uranium and rhenium answer to oxygen's retreat. Phosphorus cycles amplify eutrophy. It is a choir conducted by ocean physics and volcanism, not by furnaces. Where fly ash-like spherules should be, we find volcanic shards. Where alloy-like suites of smelting metals might march together, we see redox-loving elements that peak because the deep has turned sour, not because slag heaps smoked onshore. There is also geography in the way OAEs write. They prefer basins primed to seal themselves off. Silled margins, interior seaways, regions where circulation is naturally fragile. In some places, sediments go jet black. In others, the signal is subdued or missing because local currents refuse the script. A technological imprint, by contrast, would lean on the democracy of air. Its chemistry arrives everywhere. Rains and winds can travel, thin but synchronous, nested within the same few centimeters of mud across wildly different settings. Yet OAEs teach us how sensitive the system is to nudges that rearrange heat and nutrients. They show that carbon isotopes can pivot quickly without any story of culture, that ecosystems can shuffle abruptly when oxygen lines move, and that the rock record can hold that drama with exquisite clarity. Each lesson tightens our detector. If we meet a black shale with a negative D13C excursion, a warm-leaning D18O, trace metal enrichment, and a biological flip, we now ask, how thick is the band? Which metals lead the dance? Are there industrial spheres? Are metal ratios alloy-like or redox scripted? Do distant, dissimilar basins sing in time? Filed honestly, OAs land beside the PETM and the KPG as calibration points. Long fevers, written by oceans and volcanoes. Thin wounds, written by rock from space. And somewhere, if it exists, the slender, worldly fingerprint of intent. If we're going to hunt for an industrial echo in deep time, we first need a translation key, a layer we understand so well that it teaches us what to look for elsewhere. Conveniently, uneasily, we are writing one. Future geologists will not need our poems or our photographs. They will turn to the strata and find a narrow band where the planet's handwriting changes all at once. That band, thin, global, and weird, can be our Rosetta layer. What sits in it? First, the clock we set off ourselves. Artificial radionuclides. Mid-20th century weapons testing misted the world with isotopes that nature does not make in appreciable quantities. Long-lived signatures that let a reader date the horizon to the decade. In Lake Varves, the bomb spike is a page you can point to. In marine clays, it is a whisper that still synchronizes cores and ocean apart. Second soot written in circles. Engines and stacks rain spheroidal carbonaceous particles and fly ash spherules. Polished, glassy, iron-rich beads that wildfires and volcanoes struggle to counterfeit in the same shapes and abundance. They are tiny, but they travel. Even far from cities, they settle into that slender band like punctuation you can feel with a fingertip. Third, metals in company. Our metallurgy sprinkles sediments with ensembles: lead, zinc, copper, chromium, nickel, vanadium, rising and falling together. Not because a volcano breathed, but because furnaces did. Add mercury in patterns that don't track eruptions, and rare earth element ratios that whisper refinery, and you have an alloy-like chord that nature seldom plays in tune across the globe. Fourth, molecules that do not belong. Some synthetics fragment yet persist as stubborn residues in cold, low-oxygen muds. Others fuse with sand into plastiglomerate, half rock, half artifact. Microplastics drift offshore and become a fine seasoning in marine snow. Then a permanent pepper in the sediment. No volcano makes that seasoning. No river alone composes it. Fifth, the quiet rewrite of biogeochemistry. Fertilizer and combustion tug nitrogen's isotopes. Phosphorus pulses through estuaries. Lakes go briefly loud with algae and then fall still in the dark. In the same pages, foraminifera shells record seas that warmed and bit a little harder. The carbonate high notes dim as acid rises. Pollen tells of synchronized disturbance, grasses, weeds, and opportunists swelling across distant valleys at once, followed by forests returning where they can. Sixth, bones and bricks of a strange kind. The global explosion of domestic chickens leaves a biostratigraphic spike in compact uniform bones. Concrete and aluminum become new rocks in urban fills. Even our sand, the glassy tailings of industry, has a grain-sized story that differs from wind and river alone. These signatures are patchy, yes, but the chemistry that cushions them is everywhere the rain could carry it. What matters as much as the ingredients is the tempo. All of this arrives within the thickness of a few millimeters to centimeters. A human lifetime rendered in mud. That thinness is the silhouette we carry into deep time. If a prior civilization existed, their Rosetta layer, whatever its materials, would likely be narrow, global, and overstuffed with coincidences that ordinary geology rarely stacks. A carbon gasp, a metal ensemble, spherical ash, molecular ghosts, a biological stutter. Together, learning our own wake is not an act of vanity, it is calibration. It teaches us what intent might look like when the monuments are gone, and only the dust remembers how we lived. Every mystery has a cartographer, and ours keeps drawing oceans of blank. We talk as if the planet has told us its whole story. But most of Earth is a library we've skimmed, opening a few famous books, quoting a paragraph, and calling it the canon. If the signature of an earlier civilization is thin, global, and easy to miss, then the cruelest truth may be this: we simply haven't sampled enough pages. Start with the continental shelves, the drowned front porches of former worlds. There were river plumes laid down fine, honest layers year after year, where harbors, farms, and furnaces would have breathed chemistry into mud. Yet shells are awkward and expensive to core. We have transects, not atlases, dots of data separated by entire countries of seafloor. Polar shelves are worse, armored by ice, seasonally brutal, and stitched with hazards that keep ships cautious. If someone lived loudly by the tide 100,000 years ago, the proof might be resting quietly under a meter of silt we've never touched. Deep water pretends to be better, but the abyss is a miser. Oceanic crust older than 200 million years is largely gone, subducted, reheated, rewritten. So deep time keeps tearing out its own chapters. Even in the Cenozoic pages, we still have abyssal clays built at the pace of dust. Their stories are legible, but only if you hold them very close and very often. We don't. Our drill holes are proud, storied, and sparse. Milestones on a highway, not a street map. On land, the good archives are fewer than we pretend. Varved lakes, those meticulous keepers of year-by-year pages, are rare, and most are young. Peat bogs pickle memories, but mainly for tens of millennia, not millions. Stalagmites and stalactites write slow diaries in stone, exquisite but local. Desert playas collect dust like time-lapse photographs, yet they blink on and off with climate. Their sequences are mosaics, not films. Permafrost and old ice carry air in their lungs, but ice flows. Beyond a certain age, the pages crumple and rearrange themselves until the timeline is a puzzle with missing corners. Even where we do sample, our choices are human. We core where ships can safely linger, where permits are plausible, where funding follows familiar questions. We revisit famous events because we know we'll find them. We stitch our global stories from data near coasts wealthy enough to ask, from lakes beloved by long-running projects, from seas with peaceful weather more often than not. A thin horizon that whispers once in every 100 cores can vanish into that kind of bias. Present, but outnumbered by silence. If we're serious, we need something like a census of thin horizons, a deliberately uneven, planet-wide sweep that favors the very places we've neglected. Cross-shelf fans at old river mouths, silled basins that hoard lamine, tropical shelves under modern mud blankets, polar margins where summer windows let a ship breathe, inland lakes that layer like tree rings, and deserts where varnish grows microns at a time. At each site, the same disciplined suite. Isotopes, metals, spherical ash, molecular ghosts, microfossils, measured blind, logged openly, mapped together. The outcome might be a clean no, no synchronous, fingertip-thin band where too many unlikely things align. That answer would still be a gift. It would tell us that even loud centuries can fade almost entirely, that deep time's erasers are stronger than our imaginations. Or we might find a few strange, narrow horizons that won't behave like volcanoes, impacts, or anoxic seas, a pattern that, once seen, refuses to be unseen. Either way, the map will be truer. And sometimes, the difference between myth and discovery is nothing more romantic than drilling a little to the left and a little more often. If the planet writes in whispers, maybe we need better ears. Our microscopes can see the ash spheres. Our mass specs can weigh the isotopes. Our cores can lay a century on the table like a ribbon. But the pattern we're chasing, the slim, global chord where too many unlikely things sing at once, may be buried in noise subtle enough to dodge human intuition. So, we borrow a listener that doesn't tire, algorithms that read geology the way a conductor hears a symphony. Begin with humility. Feed the machine honest bread. We assemble multi-proxy datasets from each archive, T13C and D18O, boron-based pH, trace metal suites, counts of spheroidal particles, microfossil communities, pollen spectra, magnetics, even grain size statistics and color reflectance. Each proxy is a voice, none is a verdict. We time-align cores with the care of watchmakers, using tephraties, magnetostratigraphy, varved counts, and Bayesian age models that admit uncertainty instead of hiding it under a smooth line. Then we teach the system what natural drama looks like. We build a library of labeled segments, impacts, OAEs, Patum-like warmings, volcanic ashfalls, dust pulses, wildfire horizons, deglacial surges. For each, the model learns the multivariate signature, the way metals cluster, isotopes tilt, particles swarm, biota flip, and crucially, their tempos and thicknesses. We stress it with adversarial examples. Volcanic shards sprinkled among fly ash spheres, redox-driven metal peaks masquerading as smelting, methane burps shaded to mimic industrial carbon. The goal isn't a parlor trick. It's a detector that distrusts itself unless the whole code is in tune. Anomaly detection becomes our scout, using unsupervised methods, autoencoders, isolation forests, dynamic time warping across age model ensembles. We ask the data to point at horizons that don't belong to any known class, especially those thinner than a human lifetime when translated to sedimentation rates. We demand cross-archive agreement. A candidate must appear within age uncertainty in basins that don't talk, lakes, shelves, abyssal plains, each humming the same odd chord. We guard against wishful listening. Analyses are pre-registered. Teams are blinded to suspected zones. False discovery rates are controlled. Synthetic phantom cores, seeded with known signals, test the pipeline end to end. When the model flags a horizon, humans return to the bench. Microscopy to confirm particle morphologies, isotope labs to replicate swings, independent labs to try to break the result. If it fails, the model learns. If it holds, the circle tightens. Open data is the oxygen of this enterprise. Cores become shared scores. Raw counts, spectra, and age priors are published with code and calibration files. Let strangers in other languages rerun the song. Let them swap instruments, different mass specs, microscopes, chemistries, and see if the melody survives. A true, slender, worldly fingerprint should be stubborn across methods. A mirage will fade under a different bulb. This is not replacing geologists with gadgets. It's giving our curiosity a second set of eyes. Stone is a noisy archive. If a brief, deliberate century lies hidden in its pages, it will appear first as a statistical ache, an almost that refuses to go away, before it ever becomes a story we dare to tell. Disappearance doesn't require cataclysm. It only needs ordinary physics, biology, and time. Picture a culture that spans coasts and river mouths, the same places we prefer because food and trade move easiest there. Now run three endings. First, the slow fade. Population thins over centuries as climate edges warmer, seas nibble at deltas, and arable land migrates inland by inches. Institutions fray. Maintenance is deferred. Bridges rust in place, levees slump, power grids flicker until they go quiet. People salvage relentlessly because salvage is cheaper than mining. Copper vanishes from walls, steel from rails, aluminum from facades. Landfills, our time capsules, are quarried like ore bodies until even the language of plastics and glass is ground into anonymous grit. By the time forests reseed boulevards, the city has already been converted into parts, and those parts into soil. Second, the fast fall. A clustered run of bad years, crop failures, epidemics. A war no one can afford. Tip systems past recovery. Fires move through suburbs built for wind and drought. Water pumps stop and pipes burst. Untreated rivers erase their banks in a single season. Without constant human pressure, opportunists rush in. Vines pry stone, salt swells concrete, freeze-thaw wedges buildings apart, winter after winter. In a few decades, skyline becomes silhouette. In a few centuries, silhouette becomes hill with unusual chemistry. The archaeology of collapse is often a thin layer of ash, bones, and broken storage jars. The archaeology of an industrial collapse might be thinner still. Third, the pivot to sea. Suppose much of the economy rides offshore on platforms made to be light and recyclable. Biocomposites, modular alloys, fabrics engineered to return to biology. A storm year that comes once in 1,000 years now comes twice in 10. Hulls go down, moorings fail. Salvage does what waves miss. Evidence descends to shelves already primed to bury it. What remains in the long run is chemical. A brief, synchronous dusting of metals and spheres, a rearrangement of plankton, a swerve in isotopes, our familiar chord, played briefly and then allowed to fade. Information is the most fragile building. Paper molds, cloth rots, magnetic domains relax. Polymers cross-link and crack. Granite stelae can speak for millennia if anyone bothers to carve them. But a culture fluent in ephemeral media, Light on stone, heavy on code, leaves memory that outlives people by decades, not ages. A few vaults survive if someone still pays the bill. When no one does, climate and chemistry take over. Knowledge bottlenecks turn libraries into rumors. Rumors turn into myth. Myth returns to silence. Time scales finish the erasure. Within 100-300 years, most structures are unsafe shells draped in green. Within 1,000-10,000, roofs have fallen. Iron has returned to oxide. Glass is beach again, and floodplains have shifted over foundations. Give 1,000,000 years and mountain building, burial, heating and grinding fold the remainder into rock. Give 100 million and ocean crust, if it ever hosted anything, has been born and eaten twice. Nothing supernatural is required. The world is a solvent, and civilization is a concentrated dye. If poured thinly enough across time, the color becomes a tinge you only see when you hold the page to the light. That is what we are hunting. Not ruins, but a faint, deliberate hue. Dreaming is easy. Fieldwork is expensive, wet, and full of mud in the cuffs. If we're serious about asking the earth a fair question, we need boots on deck plans, sights, cores, instruments, and a choreography that turns wonder into data. Start with transects across drowned river mouths on three very different margins. A tropical shelf, say, an ancient delta under warm, high sedimentation muds. A temperate mid-latitude shelf with winter storms, and a polar shelf that opens for a brief, merciless summer. At each, lay coring lines from near shore to the shelf break, spacing them tightly enough to map the same few centuries across changing environments. Gravity cores take the top meters. Piston cores chase deeper. Every core is split, photographed, logged for color reflectance and magnetic susceptibility, then sampled at centimeter resolution across any suspicious thin horizons. Pair shelves with quiet archivists, a silled marine basin or fjord with laminated bottom muds, the kind that preserve year-by-year stripes. Two varved lakes at altitude on different continents, where each light-dark couplet is a single season and stray soot lands faithfully. A peat bog that has stacked centuries of wind-blown dust, and a stalagmite from a coastal cave whose drip chemistry hears whatever the rain carried. Each side gets the same measured suite, D13C and D18O, boron-based pH, trace metals, Pb, Zn, Q, Cr, Ni, V, Ag, plus ReEs. Black carbon, counts and morphologies of spheroidal particles and fly ash spherules by SEM, pollen and microfossil sensors, grain size statistics, and where young enough, radiocarbon and radionuclide profiles to anchor cream chronology. Lab teams are blinded to suspected zones. Subsamples are split and mailed to independent facilities that never see each other's numbers until the end. Navigation is everything. Age models aren't an afterthought. They're a parallel project. Tephra layers are chemically fingerprinted and matched to known eruptions to tie distant cores together. Paleomagnetic flips and excursions add rungs to the ladder. In varved lakes, years are counted twice by different hands and adjudicated when they disagree. Bayesian age-depth models keep uncertainty honest. We never pretend a fuzzy date is sharp. To keep ourselves from chasing phantoms, we build a traveling library of imposters, reference samples from known volcanic ashes, wildfire horizons, dust pulses, and redox-driven metal enrichments. Every candidate odd layer is tested against this library first. Only when a horizon refuses those categories, because too many unlikely things coincide in the same slender band, does it graduate to deeper scrutiny. All of it lives in the open. Core images, raw counts, instrument settings, code, and priors are posted as they're made. Critics choose new sites, flip hemispheres, or repeat the work with different machines. If candidates vanish under that glare, we learn our limits. If they persist, we earn the right to raise an eyebrow. This is the difference between a story and a search. A map, a manifest, a calendar, and the discipline to accept no when stone says it. And if the answer is maybe, we'll have the samples and the witnesses to ask again better. If we ever whisper the word civilization to describe a thin line in stone, the world will quite rightly ask, prove it. Not with romance or rhyme, but with evidence that corner checks itself, survives hostile scrutiny, and leaves nature with no honest alternative. What would that bar look like? First, tempo plus synchrony. The candidate must be geologically thin, decades to a few centuries in varved lakes, centimeters in marine mud, and time-locked across archives that don't talk to each other. Shelves, abyssal clays, silled basins, high alpine lakes, peat, cave calcite. If it sprawls in time, it's likely the planet. If it shows up everywhere at once, the clock starts ticking in our favor. Second, the industrial chord, not a solo. We'd need the negative D-C swing, a carbon gasp, paired with A, spherical glassy fly ash particles, B, alloy-like suites of metals, PB, ZN, Q, CR, Ni, V, rising together in ratios that match smelting and fuel, impurities rather than volcanic or redox scripts. C, molecular ghosts improbably synthesized by blind geology, halogenated fragments, polymeric residues, plastiglomerate grains, and D, a sharp ecological stutter, plankton flips, eutrophication pulses, pollen of disturbance-loving plants, stacked within the same few millimeters. Third, provenance that points to hands, isotopic accents in metals, and lead that trace ore mixing patterns rivers don't usually blend. Black carbon morphologies that scream furnace over wildfire. Nitrogen and boron stories that read fertilizer and acidification rather than dust and drought. Each proxy should survive on its own and get louder in chorus. Fourth, a nuclear whisper. Not necessarily intact isotopes after deep time, but daughter product patterns and mineral defects in crystal lattices that betray neutron fluxes inconsistent with volcanism or lightning. Even a faint, globally synchronous signature of such processes would be a flag nature rarely flies. Fifth, thickness tied to human weather. In varved lakes, we should count pages, year by year, across the horizon and see an industrial century's cadence. A quick rise, a peak, a policy-like pivot, a taper. That rhythm differentiates us from long geologic fevers. Sixth, elimination of the usual suspects. The layer must refuse classification as impact. No platinum group cocktail, no shocked quartz. Refuse the wardrobe of OAEs. Redox-led trace metal choreography without industrial spheres. And dodge the petty M's drawn-out tempo. We don't get to declare victory until every natural impostor has been invited and found wanting. Seventh, replication that feels unfairly thorough. Independent labs, blinded subsamples, different instruments, new cores, an ocean away. Same answer. Open data and code so critics can try to break the claim. If the signal survives strangers, it begins to deserve belief. Eighth, a skyborne second opinion. A matching micro-horizon in polar ices, where preserved. Lunar soils, or Martian sediments, thin, odd, and coeval, would turn extraordinary into inescapable. Earth forgets. The Moon and Mars are less sentimental. Only then would someone came before graduate from a story to a sentence we can say with a steady voice. Until that day, the honest position is disciplined curiosity. Build detectors, widen maps, invite skepticism, and let stone speak. Imagine it's a Tuesday, not a holiday, not an eclipse, just a workday that turns, very gently, into a hinge of history. A paper appears cautious and stubborn from teams that do not share languages or funding sources, but share the same thin horizon, a fingertip of mud that, everywhere they looked, sang the industrial chord. Another lab, hostile and precise, tries to break it and fails. A fourth group, people you trust precisely because they never join parades, sigh and agree. The headline is smaller than you'd expect. The tremor underneath is not. What would change? First, our place in the story. The idea that we are the first has always been a comforting frame. It flatters our beginnings and excuses our mistakes. A confirmed predecessor would replace that frame with a ladder we can fall from. Progress would no longer feel inevitable. It would feel conditional, something that must be tended, not a rail we glide along. Children would learn timelines where humanity is not the prologue to everything, but a chapter in a book that knows how to lose chapters. Second, our economics of time. Policy would gain a new axis, not left-right, but shallow-deep. If the earth can erase cities almost completely, building only for quarterly returns would look like leaving notes on a beach at low tide. We would talk more seriously about materials that either last rightly or vanish rightly, about infrastructures designed to fail gracefully, about archives that do not assume electricity forever, about stewardship as a technology, not a sermon. Third, our ethics of neighbors will never meet. To admit predecessors is to admit obligations to successors who will never meet us either. We would have to write for them the way we wished our elders had written for us. Clear, durable, humble. That could mean small things. Open data that survives formats, teaching as a civic act, and large things like choosing how we leave the atmosphere, the oceans, and the shelves. The moment you know the archive is stingy, vandalism and generosity both gain weight. Fourth, science would change its posture. Paleontology and stratigraphy would become even more interdisciplinary, not as a fashion, but as a necessity. You'd see isotope labs next to machine learning teams next to philosophers of evidence. Funding would bend toward long, careful projects that cannot promise headlines every year. Deep time observatories spread across shelves and lakes, calibrated once and read for generations. The reward structure would have to make room for patience. Fifth, faith and myth would breathe differently. Some beliefs would fold the finding into their stories. Others would resist. But even resistance would be a conversation with time, not just with power. Art would answer first, as it always does. Then law, then custom. We would write new lullabies that teach not only how special we are, but how brief. Finally, our sense of risk would mature. If industry has already happened and been swallowed, then disappearance is not a thought experiment, it's precedent. The question, can we, would share space with should we, and for how long? Not as scolds, but as engineering constraints. Resilience would stop being a buzzword and start being a blueprint. Redundancy, recoverability, rights of way for rivers, sacrificial zones designed to break cleanly so the rest can hold. Discovery would not make us smaller. It would make the room larger. It would ask us to act like we know we're being watched, not by gods or enemies, but by the pages of the planet and by children not yet born, who will someday read how we behaved when we learned we were not alone in time. If Earth forgets almost everything, then legacy is a materials problem, a cartography problem, and a humility problem. We don't need a monument to us. We need a message for whoever reads the rocks after we're gone. Something that survives erosion, politics, and fashion, and is legible to a mind that may not think like ours. Start with first principles: redundancy, diversity, simplicity. Redundancy means many copies in many places. Diversity means different media: stone, metal, ceramic, glass, ice, moon dust, because no single archive is safe. Simplicity means the message can be decoded from scratch, with pictures and ratios before poetry and law. If your first page requires a Rosetta Stone we forgot to leave, you left a riddle, not a record. Materials are the grammar. Polished sapphire and fused quartz can hold micron-deep etchings for millions of years if kept dry and dark. Dense ceramics outlast metals in salt and soil. Titanium and tantalum sulk instead of rusting. Nickel can carry high-resolution engravings. Alumina and diamond-like carbon shrug off heat. Paper is kindness to decades. Stone is kindness to ages. Wherever possible, encode shapes, scales, and processes. A human hand beside a fern frond, beside a nautilus spiral. A ruler cut into the margin in base 10 and base 2. Star maps anchored not to constellations but to pulsar periods and fundamental constants. Mathematics is the only language we know that doesn't assume our metaphor. Where to put it? High, dry caves above floodlines. Arid salt mines with stable temperatures. Desert lava tubes. Polar nunataks rather than permafrost that will thaw. And beyond weather, the moon. Lunar regolith abrades. but a meter of burial turns millennia into sleep. A chain of quiet libraries in widely separated sites, each copy complete, each one pointing to the others, gives time less leverage. Space archives should be dull and dense, not glittering. Micrometeoroids respect mass. Biology is tempting. DNA inscriptions in hardy spores, seeds, or synthetic chromosomes. But evolution edits without asking. If we write in flesh, we need error-correcting codes, multiple checksums, and decoders etched in inert matter nearby. Better to treat biological messages as living footnotes, never as the only book. Legibility matters more than lyricism. Pictograms of counting, gravity, orbits, the hydrogen line, drawings of eclipse geometry, timelines scaled by known radioactive decay chains, diagrams of how to build the instruments needed to read finer pages. Then, only then, history and counsel, how we farmed without breaking rivers, how we built cities that failed gracefully, what traps we fell into when we mistook speed for progress. A warning is useful only if the reader can believe it and repeat the test themselves. There is an ethical edge here. We could, in theory, seed a deliberate geologic horizon, an engineered thin line in lakes and shelves that broadcasts intent for deep time. But the cost is burdening future ecologies with our proof. Better to leave messages that do not scar. Durable libraries, reversible signals, infrastructures designed to return to benign chemistry when unattended. The last piece isn't hardware, it's habit. Cultures endure when copying becomes ritual. Annual recutting days where communities re-engrave key plates. Apprenticeships that pass down how to rebuild decoders from junk. Mnemonic epics sung alongside the etchings so that forgetting has to fight both stone and story. Writing to the far future won't save us. But the act of trying, of choosing durability, legibility, and restraint, changes how we live now. It makes us the kind of ancestors we wish we'd had. If the ground itself is forgetful, the lesson isn't despair. It's design. Survival in deep time is not a single invention, but a grammar. Habits that make collapse less likely and recovery kinder when it arrives. Imagine we are building a city with its future readers in mind. A place that expects both sunshine and silence, prosperity and pause. What rules would we etch into its bones? Begin with materials that either last rightly or vanish rightly. Last rightly means ceramics that sulk in salt, stones that shrug at water, alloys chosen for passivation rather than polish. Vanish rightly means composites that compost without toxins, polymers that become food at the end of their shift, paints that fade to minerals, not microplastics. Between the two is the sin to avoid, stuff that lingers as poison. Energy must whisper. A grid that depends on a single heroic fuel teaches fragility. A web that braids sunlight, wind, moving water, heat in the ground, and the gentle work of microbes teaches patience. Storage is not just batteries. It's cold brine, hot rock, elevated mass, pumped ponds, and the steady reserve of habits that use less when the sky is stingy. The measure of a good system is how boring its outages are. Build for graceful failure. Levees fail forward into parks, not neighborhoods. Bridges sag into safe modes instead of falling clean. Sea walls hide retreat roads behind them. When the line must move, the road is already there. Software degrades into hand tools. Hospitals rehearse paper. Elevators teach stairs how to carry stretchers. We don't pretend we will never be without power. We practice being fine without it. Rights of way belong to rivers, roots, and wind. Floodplains are not real estate. They're organs. Corridors for pollinators, migratory paths, firebreak meadows. These are not amenities, but infrastructure. A city that breathes with its watershed can survive storms a spreadsheet never warned about. Designed for salvage. Every building carries an anatomy tag, readable by eye, indicating how it comes apart and where each piece goes. Fasteners are standardized, adhesives are shy, hidden cavities are rare. Appliances tell scavengers their element maps. Landfills are mines by design, sorted strata rather than heaps. We code recovery into the object the day it's born. Redundancy without waste. 2 ways to get water, 3 paths to get food, 4 to share a message. None of them glamorous, all of them maintained. Critical skills are duplicated across neighborhoods the way seeds are duplicated across fields. The city assumes a snow day for systems. Life continues anyway. Culture is the flywheel. Rituals keep copies alive. Annual drills that are festivals. Recutting days when kids learn to sharpen tools and re-etch plates. Communal audits where we follow a meal to its farm and a bolt to its mine. Stories teach what signs to watch in fish, in moss, in the color of the river at noon. A resilient city is a school that never closes. Measure with honest clocks. We budget carbon and nitrogen the way banks budget cash. We keep a ledger for soil and sand. We weigh the future cost of sand into every window. If a process would generate a signal that future rock might misread as harm, we ask if there's a kinder route, and we prove it in small before we scale it to large. Finally, designed for being read. Put quiet libraries where stone will keep them. Pair every ledger Silurian with diagrams a stranger could decode. Leave tools and recipes, not just warnings. If we vanish, the next hands should be able to rebuild a stove, a pump, a microscope, then decide for themselves what to cook, what to irrigate, what to study. None of this guarantees staying. It does something harder. It makes leaving gentle. It teaches us to be the kind of ancestor whose absence is not a wound. And that is perhaps the only kind of permanence a restless planet will honor. Suppose the cleverest tools a vanished culture made weren't towers or turbines, but living things, organisms rewritten to harvest energy, heal landscapes, or carry messages the way trees carry rings. Stone is stingy, but life makes copies of itself. Maybe the longest lived archive on Earth is not granite, but heredity. If technology ever wrote in flesh, could any of its ink remain? Start with the obvious caveat. Evolution edits without asking. Mutations shuffle letters. Selection trims extravagance. Drift smears signals. And time is the great typesetter that resets the page. Over millions of years, even bright sentences become accent marks, then smudges. Still, some smudges are diagnostic. Synthetic biologists today sometimes leave deliberate watermarks in DNA. Phrases encoded in redundant codons, prime number patterns, parity checks, or sequences that translate into nothing except a wink to future readers. Those marks can be made robust against mutation by repetition and error-correcting structure. If a prior civilization played the same game at scale, in crops, microbes, or reef builders, faint statistical oddities in codon use or motif frequency could persist as a bias we can still measure. Look for recoding. Natural genomes mostly agree on which three-letter words specify which amino acids. But a technological culture might have reassigned the alphabet to protect engineered organisms from wild viruses, or to keep them from interbreeding with their untuned cousins. That kind of genetic firewall leaves telltales. Systematic departures from the universal code, unusual absence or surplus of certain tRNAs, or amino acids that are rare in biology appearing with suspicious regularity. Deep time would prune such systems, but fragments might echo in lineages that found stable niches. Search for chemistry that biology almost never uses. A prior age might have favored non-canonical amino acids, xenonucleic acids, or base pair variants. because they conferred heat tolerance, UV resistance, or controllable lifespans. Those exotic chemistries are fragile in rock, but their footprint could survive as odd clusters of enzymes specialized for making or degrading them. Gene families with peculiar active site motifs recurring across unrelated taxa, as if borrowed from an old toolbox. Gene drives, selfish elements that bias inheritance, are another hypothetical signature used at scale to control pests or restore keystone species. They could sweep through populations quickly, leaving behind distinctive scars, guide sequence motifs at conserved loci, repeated palindromes that function as homing beacons, or telltale patterns of resistance evolving in lockstep across continents. Over geologic spans, drives fade. But in younger, deep time, their ghosts might linger as synchronized haplotype quirks in distant archives. Permafrost DNA, lake mud DNA, cave guano laminations. Domestication narratives also carry long memory. Bones thicken, horns shrink, seeds swell, genomes bear bottlenecks and sweeps. If we ever found a lineage, marine or terrestrial, with a domestication signature out of place in time and ecology, say, a reef organism with synchronized selection sweeps across basins that never touched, we'd have to ask who did the selecting. Nature domesticates too. Ants herd aphids, fungi farm leaves. But its geographies are local and its tempos varied. Culture tends to synchronize. Humility, always. False positives abound. Viruses rewrite genomes with breathtaking indifference. Endosymbionts tinker with codes. Extreme environments favor exotic enzymes. The right response isn't to declare every odd motif a message. It's to build a library of natural weirdness, then look for patterns that resist those explanations and recur where the rocks already whisper something brief and global happened here. If technology once wrote in flesh, its afterimage won't be a sentence we can read aloud. It will be a statistical ache. Codon biases out of place. Enzyme families that don't fit their phylogenies. Domestication clocks that chimed in unison a very long time ago. Thin, doubtful, and yet, if stacked with the chemical code in stone, suddenly persuasive. There's a quiet courage in a negative result. It doesn't make headlines sing. It makes foundations sturdier. Suppose we comb shelves and lakes and caves, teach machines to hear stone, and the stacked chord never appears. No fingertip-thin horizon that refuses all natural explanations. Just Earth, loud and inventive, telling her own stories. That no would not be emptiness. It would be a map of limits. What the planet can imitate, how quickly it heals, how faint even loud centuries become when time turns the page. A clean no resets our mirrors. It frees us from the flattering idea that meaning fills the world wherever we look. We are not obliged to invent predecessors just because we long for elders. Instead, we face the humility and the thrill of being early. A species that might be the first to knit tools, language, and global scale into a single braid on this world. Not the first to feel, to plan, to teach. Other animals do those things. But perhaps the first to trouble the isotopes on purpose and send metal into orbit. If that's true, the weight of our choices grows, not shrinks. There is no example to copy. The pages ahead are blank. No also sharpens our detectors for the things that do matter. In learning to separate industry from volcano, we get better at telling climate stories in their own voices. We refine baselines for acid oceans and breathless seas. We time the pulses of carbon that nature alone can throw. We hear the difference between wildfire and furnace in a single grain of ash. Those skills aren't souvenirs of a romantic quest. They are instruments for stewardship now, tools for reading the present with the same rigor we demanded of the past. And no can be a love letter to the future. It says, we looked carefully. We didn't find ghosts. Here is the library we built anyway. Course, methods, open data, so that you can look again with better eyes. It models a culture that values patient, collaborative truth over spectacle. It proves we can want wonder and still choose discipline. It shows children that mystery isn't a loophole for belief. It's a corridor for work. Most of all, no clarifies what survival asks. If Earth forgets nearly everything, then permanence is a practice, not a property. A negative result tells us the archive is stingier than stories suggest. Monuments will fade, and so will we, unless we design for gentleness. Materials that return without harm, systems that fail gracefully, libraries that don't assume light forever. Whether or not someone came before, we can still decide to be the kind of ancestor whose absence isn't a wound. There will always be a temptation to gild the silence with certainty. Resist it. Let the rocks answer plainly, and let your awe remain intact. Wonder doesn't require a yes. It requires a question asked well, an ear patient enough to hear the smallest reply, and a willingness to live differently because you listened. Certainty is a lovely drug. It makes speeches smoother and budgets easy. But the world we actually live in is built out of probabilities and partial maps. And maybe is the word that lets us keep walking without lying to ourselves. In the hunt for predecessors, maybe is not a shrug. It's a steering wheel. It keeps our hands light, our eyes open, and our method honest enough to survive our hopes. Maybe changes how we plan. When you admit the archive is stingy, you build work that pays off even if the headline never arrives. A shelf core campaign that fails to find the industrial code still refines climate baselines, sharpens age models, and trains a generation to read thin horizons. A machine learning detector that never flags a prior civilization still learns to separate wildfire from furnace and OAE from impact. Skills we need for our own century. Maybe makes the byproducts the point. Maybe is a design constraint for policy too. If Earth forgets quickly, then we build as if our monuments will not defend our memory. We choose materials that return harmlessly when unattended. We choose archives that don't assume electricity. We design cities to fail into safety, not into tragedy. We ride to the future in redundancies, not in single points of failure. Maybe trades swagger for resilience. It also civilizes debate. A clean maybe invites the skeptic into the room without ceding the floor. It says, "Here are the tests that would change my mind. Here are the imposters we've already eliminated. Here is what we still don't know and how we plan to find out." That posture turns argument from theater into craft. It makes replication possible and dissent useful, because now the disagreement is about measurements, not identities. For education, maybe, is the antidote to cynicism and to credulity at once. Show a child a varved lake slab and let them count winters with a fingertip. Show them an ash sphere under a microscope and a bit of shocked quartz. Show them how a story becomes a hypothesis, becomes a method, becomes a result that is proud enough to be wrong. They will learn that wonder isn't the opposite of rigor, that the heart can be full and the notebook neat at the same time. A culture that teaches that is harder to fool and easier to inspire. Most of all, maybe, keeps humility alive without dimming ambition. We can build detectors, widen maps, and aim instruments at the moon while admitting we might end with a graceful no. We can spend carefully and still admit that discovery isn't guaranteed. We can love a question more than we love applause. In a noisy age, that's a radical way to live. If someone came before, maybe will get us there honestly. If no one did, maybe will still have given us a truer map of our planet and a kinder blueprint for staying. Either way, the work is worth doing, because the work improves the hands that do it. The ship rolls like a slow metronome as the winch hums and the wire pays out. Silver cutting the slate green water. Science is often a mood more than a moment. And today, the mood is disciplined hope. We are not chasing Atlantis. We are chasing millimeters, thin horizons that might, if we are lucky, hold a century's worth of breath. The first gravity core comes up pale and shy, a column of seafloor pressed into translucence by the liner. We lay it on the rack as if it was sleeping. Split, describe, photograph, log. Color reflectance sings a soft gradient. Magnetic susceptibility murmurs back. At 78 centimeters, a narrow band darkens. A few millimeters of fine silt-rich mud. Interesting is all anyone says. The word scientists use when their heart steps forward but their feet do not. Samples are taken at a spacing stingy enough to feel like greed. The spherules count, measured blind elsewhere, will take weeks. But a quick microscope peek shows a handful of spheres so round they look posed. Are they volcanic shards fooled by the light? Or are they the smooth iron-rich beads industry makes? We log the ambiguity, not the thrill. A second sight, closer to the drowned mouth of an old river, yields a cleaner story in laminy. Dark light, annual pages you can hear as much as see. At one thin couplet, diatom species flip like a shoal turning. Opportunists in, specialists out, then flip back 10 years later. In the same 2 millimeters, organic carbon nudges higher. Nitrogen isotopes tilt toward fertilizer's accent. It could be floodplain farming. It could be a natural nutrient pulse. The point is not to decide now. The point is to stack clues without letting hunger write the ending. Onshore, a high country lake gives up a slab as tidy as lined paper. We count years across a faint, soot-dusted interval under a magnifier. 29, 30, 31. The soot particles are angular, wildfire's signature, not fly ash's polish. Good. A false positive eliminated is a door locked behind us. Back on deck, rain needle sideways. Someone makes coffee strong enough to stand a spoon. We agree, out loud, to the discipline. Every candidate horizon will be vetted against the imposter library first. Known ashes, wildfire layers, redox-driven metal peaks. Only if a band refuses all of those wardrobes do we bring out the heavier instruments. Lead isotopes for ore mixing, boron for pH, electron microscopy for particle genesis. What we're building isn't proof. It's a funnel, wide at the mouth. Let everything in that looks odd, narrow at the throat. Only those horizons that survive every natural explanation can pass. Most will not. That is success too. At night, the sea goes glassy. The cores in their racks look like candles in a chapel. Each wick an unanswered question. If the industrial chord was ever played before, it is somewhere in columns like these, thin as a fingertip and easy to miss. If it never was, these same cores will teach us to read our planet more truthfully. Either way, tomorrow we drill again. In the end, our question returns to where it began. A quiet room, the world dimming to its night sounds, and a thought that will not let go. Maybe we are the first. Maybe we are the latest. Either way, the earth is not obliged to keep our secrets or our triumphs. It files them under pressure and time, and when it reopens the drawer, the labels have slipped. What we can claim is not certainty, but care. The promise to ask well, to listen honestly, and to act as if our century matters to more than just us. We walk the map that refuses to sit still. Shelves that bury, mountains that erode, seas that breathe. We learn to look for patterns instead of monuments. The carbon gasp, the fly ash circles, the alloy-like metals, the molecular ghosts, the sudden shuffle of life. We kept a skeptic in the room and let nature play all of her best counterfeits. Impacts and lava, anoxic seas and long fevers, so that if anything remained, it would be something we could name without flinching. We taught machines to hear stone, and they taught us humility. We planned expeditions that would be worthwhile even if all they returned was a better baseline. Along the way, the question changed us. No became a kind of courage, a gift of boundaries. Maybe became a discipline that keeps wonder from curdling into wishful thinking. We learn to write to readers we will never meet, not with glittering statues, but with libraries that stone and moonlight can keep. We sketched blueprints for staying, cities that fail gently, materials that either last rightly or vanish rightly, cultures that rehearse resilience until it becomes a festival instead of a fear. And if, one Tuesday, a fingertip-thin horizon turns up everywhere at once, if too many unlikely things sing together in a single, slender band, then the room will feel larger, not darker. The discovery will not make us small. It will make our gratitude specific. We will know in our bones that the ladder has rungs below us, and therefore can have rungs above us too. We will have elders in time, and students we will never see. That knowledge will not rescue us. It will invite us to be worth remembering, even by a planet that forgets. For now, we do the work. We drill a little to the left and a little more often. We publish methods like recipes, not like spells. We teach children how to count winters in laminage and how to read a single ash sphere for what it is and is not. We leave rooms clean, waters clearer than we found them, archives that do not assume the lights will always stay on. We make our century legible so that if anyone listens later, they can hear not only what we did, but what we try to do better. The door we leave open is not to the past, it is to each other. Ask well, listen well, build gently, write clearly. If someone came before, these are the habits that will let us meet them honestly. If no one did, these are the habits that will let someone after us meet us with grace.